Hello everybody, this is Miss Pye again. In today's lesson we just went over several pages of the notes. So you want to just get your notes out and find each page that's on the screen. We will skip over one little section and we'll get to that tomorrow, but in this video we're just going over notes. There's no worksheet for it. Okay. So the first thing we want to talk about is different terms that all mean the same thing. So like if you were on the East Coast and you wanted to order a soft drink, you would ask for a soda. Okay, if you were in like Alabama or somewhere, you might say pop. Or if you were in like, I don't know, kind of somewhere in the north, you would say pop. If you're in Texas and you order Coke, the person you're ordering from will say, what kind of Coke do you want? Because just depending on which region of the United States you're in will determine which term you will use. Okay? Well, you get the same thing with your math terms. Right up here we have rectangular form and working form. On the notes it says standard form. Okay, those are all three terms that mean the same thing, and it just depends on where you are will determine which term is being used. And if you're taking this in college, it depends on where your professor went to college or where the textbook was printed or whatever. Okay, so all three of these words all mean the same thing. I'm showing you all three so you will recognize it. You will have some worksheets that will say standard form, some of them will say working, and some will say rectangular. Just be aware that they could all mean the same thing. Now, yesterday we went over the h and k value for your ellipse and your hyperbola. We really did not do very much with changing from parametric form to standard form for the circle or the parabola. We're going to look at that really quickly today, but we're not going to do any of the crazy stuff we were doing yesterday. The main reason why is because it's so stinking easy to switch from standard form or rectangular form from parametric form. The things that you need to know about are the value for your h, your k, and your r value. And first, if you're in parametric mode, all you do, find the h, k, and r, and then just place them in the format that you need for standard or working form. That's all you have to do. If you're in the standard form and you want to put it in parametric form, find h, k, and r, and then switch the locations of those values. Okay, that's it. You do want to be aware that with standard form, you will need to switch the signs for your h and your k value. Okay, I am missing a page. Oops, let me do something real quick. There we go. Sorry. All right. So in your notes, they want you to explain what H, K, R, and R represent. I'm just going to uncover the answers. Please do not write this word for word. You can just, probably 5, 6 words or less, you can summarize it. Your H and K tells you the location of the center of the circle. Your R is just the radius, okay? In the notes, you have 3. You need to draw 2 circles. You need to figure out what the parametric formula is when they give you the standard formula. You need to figure out what the standard formula is when they give you the parametric formula. And then the last one, they give you the graph, and you have to figure out what the standard and parametric form is. I will do a couple of the things, and then I want you to do the rest on your own. So let's look at this first one. Your H value is here, your K value is here, and the squared R term is there. So when you're setting up your equation in parametric form, do the little sideways mustache, x equals, y equals, cosine is always paired up with x, sine is always paired up with y, and then remember to switch the signs for your h and your k, so it's going to be positive 2 there, negative 3 here, and then your radius is the square root of 25, so your radius is 5. You should be able to do all of that without a calculator. Okay. When you plot the graph, first find the center. So we want positive 2, negative 3. So the center is approximately right there. I'm going to go up 5 tick marks, right there, down 5 tick marks, approximately right there, over to the right 5. It does get a little bit difficult when the lines are really hard to see. So those are the center of your circle, and then the radius. Kind of draw a circle, kind of, sort of. All right, there we go. Good enough. All right, so now next one, parametric to standard form, H, K, and R. Okay. Don't forget to switch the signs. So it's x minus your h. H is -5, so the x plus 5 squared plus y minus k, so -1 squared, and then the square root of 10 squared. The square root and the 10 cancel each other out. Or sorry, the square root and the squared cancel each other out, so it's just 10. Okay, again, find the center of your circle. So it's at 5, 1, 2, no, -5, 2, 3, 4, 5, and +1. So the center is approximately right there. Most of you are thinking, okay, wait, what is the square root of 10? Well, the square root of 9 is 3, so I'm going to assume that the square root of 10 is just a little bit more than 3. So just a little bit past the 3rd tick mark. Right there, right here, and let's see, no, right there, approximately. Okay. Oops, my circle's all goofy. Let me see. 1, 2, and a little bit more there. All right, so whatever. It's close to a circle. I'm not super picky. All right, when you have a graph and it's hard to see the grid lines, just kind of estimate where the center of this circle is. I will tell you on this one, that's your center. So this point at -2 and -2, that's where the center of this circle is. So parametric form, it would be -2, -2, because that's our center, plus and plus, cosine t, sine t. You need to figure out what our radius is. If you count the tick marks, I want to say it's 8. Looks like 8. We'll just say 8. Okay, there we go. Standard form, x, change your sign, so plus t, 2 squared, y plus 2 squared, and then 8 squared is 64. All right, next page of the notes, same thing for your ellipse. We've kind of gone over this already. H and K tell you the center of your ellipse. The A and the B tell you your vertical and horizontal radius. I'm not going to do the graphs on these too much. You should be able to do that. This one, there's the center of your ellipse. Once you know what your H and K and A and B values are, just plug them into your formulas. So on the parametric formula, it would be your x equals -1, don't forget to change your sign, plus the a squared is 25, so the square root of 25 would be 5, and then cosine t, the y formula would be +3 because we changed our sign, and then square root of 4 is 2 times sine t. Okay, do your little sideways mustache there. I will let you draw the graph on that one. You know where the center is, you know where the vertical and horizontal radius is. Okay, so now we have parametric form and we want standard form. X, switch your sign, so it'll be x minus 2 squared, and then square your radius, so 3 squared would be 9, and then plus, see, y, you know what? I'm not adding or subtracting anything to the y equation, so it's just going to be y squared, and then square root of 34 squared is just 34. and then that equation equals 1. Okay, there you go on that one. I will tell you this one, some of you might be thinking, okay, how can I possibly graph this? Well, your x horizontal shift is over 2, so the center is right there. Your radius, horizontal radius is 3, so there's those tick marks. And then the square root of 36 is 6, so the square root of 34 is probably a little bit less than 6. So 1, 2, 3, 4, 5. Let's go almost to 6. 1, 2, 3, 4, 5, almost 6. Okay, just get kind of close. Oh man, that totally missed it over here. So, yep, there we go. Isn't that pretty? There's my ellipse. All right, I want you to draw the graph for the first ellipse and then figure out the standard and parametric functions for the third ellipse. You can do that. We never went over the rectangular form and parametric form for the parabola, mainly because you've seen these types of functions tons and tons of times. And in this case, your h and your k, normally it would be the center. Your parabola do not have centers, but they do have vertices or vertexes. So the h and k is going to tell you the point of the vertex. So these points here, 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 and here, those coordinates are your h and your k value. Okay? And then what effect does A have on it? Again, this is a whole lot to write, so please do not write this word for word. Go ahead and summarize it. So A is going to affect how wide or how narrow your parabola is. Oops. So if you break this parabola in half, the A value is the half of the distance there. Okay, so that's going to make it either bigger, wider, or farther apart. And if A is negative, it's going to flip it. So this would have a negative A here. This would be a positive A up here. And then this one would be a positive A here and a negative A there. Okay. Let's see. H and K is vertex. A is A. Yeah. All right. So now let's look at these 4 graphs and the 4 equations. First, figure out what the H and the K value is for all of the formulas. Here, your H is positive 4. Remember, you're switching your signs when you're working with rectangular functions for the H and the K value. So H is 4, Y is 3. For this one, H is 3. Oh, excuse me, negative 3, and Y is positive 4. Focus on where your H is and where the K is, okay? K is always paired up with your Y. H is always paired up with your X. This one here, your third function, is going to be positive 3, negative 4, and then the last one would be positive 4, positive 3. Okay, notice you do have a negative there. I know it's really hard to see, but there is a negative right there. Let me trace it. There is a negative sign right there. That's going to be your negative A value. Don't forget what that does. All right, so let me erase some of this stuff. When Y is squared, your graph is opening to the left or to the right, and so graph B and graph D will be formulas 1 or 4. And then when X is the squared term, you're opening up or down. So graph A and graph C is going to be formula 2 or 3. Okay, now look at the location of the vertex. This one is 1, 2, 3 over, 4 down. So that is 3, negative 4. This one is negative 3, 4. Okay. So that tells us that, let's see, graph number, or formula 2 would match graph C. And formula 1 would match, or sorry, formula 3 would match graph 4A. Oh my goodness, I'm getting my numbers and letters mixed up. All right, let's look at graph B and D. This one is opening to the right, so my A is positive. This one's opening to the left, so my A is going to be negative. And A is positive for 1, and A is negative for problem 4. Okay, we're going to skip that next table on this page, and let's find this page. Okay, we've kind of gone over the hyperbolas a lot. Biggest thing from here, we need to realize that the dotted lines are your asymptotes. All right, your dotted lines are your asymptotes, and your slope for the dotted lines, or for your asymptotes, is just going to be B divided by A. And you're going to have one slope that's negative and one slope that is positive. Okay? To find, I'll show you how to find the equation in just a minute in the example. All right, I do want you to know about some of these similarities. Please don't write it down word for word. Just kind of summarize it, please. If you need to, take a picture or pause the video so you can summarize this. All right, a couple things you need to remember is that it depends on where the secant formula trig function is, and that will determine if you're opening left or right or up or down. Now, because secant is attached to the x formula, you're opening left and right over here, and then on the right side, secant is attached to the y formula, so we're opening up and down. Okay, but notice on your standard form, whoops, that was a little bit too much. On the standard form of the equation, or rectangular form of the equation, we always want our x value, or our x fraction, first. Okay, so what you're going to do for that, when your hyperbola is opening up and down, just make the fraction, the x fraction, negative. So when you just have your standard form of the equation, you look for which fraction is going to be positive, and that will tell you whether you're opening left and right or up and down. All right, next page of the notes. We are going to graph this completely by hand with no calculators. Okay, first thing you want to do, find the center of your of the hyperbola. It's going to be -2, +3, so -2 up 3. I'm going to change my pen color to red so that my asymptotes are in red. -2 up 3, there's the center. My horizontal radius is going to be 4, 1, 2, 3, 4. 1, 2, 3, 4. So 4 units to the left and right. My vertical radius is going to be 3, 1, 2, 3. 1, 2, 3, and then I can go ahead and create a box there, do the box in dotted lines. Okay, this box is going to guide us on where the asymptotes are. Okay, if you need to, go ahead and use your school ID to create the dotted lines. You want your dotted lines, your asymptote, to go from one corner of the box to the other corner and beyond. You want it to intersect the center point. Okay, so we now have our asymptotes. Okay, now we want to draw the hyperbolas. Check and see which one of the equations is positive and which one of them is negative. In this case, your x value is your x fraction is positive, so the parabola is going to open left and right. The vertex is going to start right there at the edge of the box, and then it's just going to follow the asymptotes. Okay, there we go. All right, let's start answering these questions. Use the standard equation to find the y-coordinates for the points on the hyperbola. Okay, so we're x equals 10. Plug in 10 for x. Right over here, we're just plugging in a 10. So 10 plus 2 is 12. 12 squared is 144. 144 divided by 16. Use your calculator if you need to. That will give you 9. And then minus y minus 3 squared divided by 9 equals 1. Okay? The easiest thing to do now, take your 1 and take this fraction and just switch them. Okay, switch places. That will give you 9 minus 1, which gives you 8, equals your fraction y minus 3 squared divided by 9. To get rid of that 9, multiply by both sides by 9. You have 8 times 9 gives you 72, equals y minus 3 squared. To get rid of the squared, you do the square root. When you take the square root of a number, your answer is going to be positive and negative. Now we just need to get rid of the negative 3. So your equation, or your y value, is going to be 3 plus and minus the square root is 72. You can plug that into your calculator and you'll get, I want to say, approximately 11.5 and negative 5.5 there. All right, so now we need to get our slope. In this case, the formula for the slope was b over a. One of the slopes would be positive, one of the slopes would be negative. So m equals b is going to be 3 and a is going to be 4. So I'm going to have a 3/4 and a negative 3/4. Okay, for the equations, this asymptote that starts on the left and increases is going to be y equals positive 3/4 because it is increasing times x plus your y-intercept. This equation that's decreasing is going to be y equals negative 3/4 times x plus its y-intercept. So now to find the y-intercept, we know that both asymptotes are going to intersect at negative 2 and 3. So plug those in for your x and y and solve for your b value. So we get 3 equals plus and minus 3/4 times negative 2 plus b. Okay, we want to find our y-intercept. If you multiply all of this here, you get 1.5, I think, negative and positive 1.5. So then you need to add and subtract them to the 3. So b is going to equal, let's see, 3 plus 1.5 would be 4.5. And 3 minus 1.5 would be 1.5. Okay, so now you can look at your graph. Which one do you think has a y-intercept at approximately 4.5, and which one has a y-intercept at approximately 1.5? You can look at those lines and you should be able to tell right away. So this equation is going to have a plus 4.5 for the y-intercept. This one over here is going to have a plus 1.5 for the y-intercept. Last thing you want to do, plug in 10 for this x and this x. Solve for y. I will tell you, you are probably going to get that y is approximately 11.5 and negative 5.5. Okay, how do I know that? Well, because your graph up here, your hyperbola is also going to be approximately 11.5 and negative 5.5. If you look around this part of the graph here, you'll notice that the lines right here are really, really close together. That's because the asymptote and the graph are converging, or they're getting closer and closer together. All right, there's one more page in your notes. I want you guys to do this page completely on your own. Because we have so many examples in our notes, I am going to be collecting your notes and grading them at the end of this unit, so make sure you get them all filled out. I will be grading them, okay? All right, so finish filling these out and complete your notes, and I will see you in class on tomorrow's Friday. Oh my gosh, it's already Friday. Holy cow. All right, see you tomorrow.